Okay, so I'll record this lah, in case who cannot come can refer also lah. Okay, I believe even though you have this book, but like no time to do or what we do together here lah. And as revision, you can take the book with you, the last year Form 4 module. You may not have textbook, but never mind, you can use last year Form 4 module or this formula. Sorry, no, this definition. So in case some of you haven't opened this before, actually this was given to you on Wednesday. Okay, so in front is formula. This time the formula will be given in laminated paper, all right, in Taman Sila. All right, so this is the exam format. I think all of you know paper 1, paper 2, very familiar. Just paper 3, I'll have one class to be practice the paper 3, all right? So for this time, for Taman C, we only count 140 lah, all right? So the learning skill number 1, understand, means you need to memorize the definition, then calculation, comparison, modification, and making decision. Okay, I think most of you very good already, but in case some of you still not yet master the skill yet, so I would tell lah. Then I will simply choose someone to answer, all right? Just want to make sure you really get it with me, all right? All right, so now this is the concept graph. Since you all learn maths and MS, this one will be easy for you. Now, so here is some reason. Implication means the reason why you choose it for your modification. For example, you choose some material with low density and then you blank. What can I write the reason? You can refer here, lighter, smaller mass, less compact. And I encourage you every time write at least 2 reasons as backup. Okay, so let's say reason number 1 failed, wrong, but you still got second reason to get marks. All right. Okay, so now next, specific heat capacity. This one very important because many people misconcept here. Why we should use a small specific heat capacity material? Because it can heat up faster or cool down faster. Okay, so must tell about the time, must mention about the time. Okay, specific heat capacity means shorter time, raise temperature more. Okay, so must mention timer, specific capacity. Then, normally this is for conductor lah. This is also for conductor, heat conductor. So this is for heat insulator. Okay, so this is specific latent heat. Okay, latent heat. So what is latent heat? Means need less heat to melt or freeze. So as we learn chemistry, we learn the cooling and the boiling graph, right? The melting graph and the heating graph and the cooling graph. So the heating graph like this. the cooling graph like this. Okay, so where is specific heat capacity located? It's around here. When there's no change of temperature. Okay, means it's for boiling. For heating graph, this is the heating graph. This is the cooling graph. So then the heat energy is used for what? For this one, we say break the bond. Okay, but for this one is remake the bond. Remake the bond. Rebuild the bond. Okay. Any questions you can type or you just raise hand and ask, all right? Or if you're really shy at the end of the class, you can stay back and ask, no problem. For heating graph, yes, Aaron, yes, please. Do you mic on mic faster? Can we write overcome the attraction force? Can use the very good. You ask question for everyone. Yeah, I believe many people also want to ask this question. Overcome the attraction force. Can use back the chemistry word can. How to see solid or solid liquid? So think back about your naphthalene. Naphthalene, remember your first experiment? If you really join and observe, you'll find out, first of all, this is naphthalene. Naphthalene. I'm not sure what is it, how to spell it. What happened? Hey, what happened? Recently, I write things and it disappeared. Okay, naphthalene. When you heat up the naphthalene, I write naphthalene. It's solid. So this part is solid. Okay. That's why when you do experiment, if possible, maximum 3%. If possible, 2% per group. Then you will have more chance to handle the experiment. Okay. So
heating and the solid liquid is in between the flat line.
Yeah, it's here when temperature is constant. If I'm not mistaken, naphthalene 78, right? Temperature. So yeah, here is solid and liquid. Until all become liquid, then only it rises up, all become liquid. Am I answering your question? Is it okay for you? Why no one answered me? I thought you asked a question. Okay, Chen Tao, yes, thank you. Okay, so now next, just tell you that this is the reason. If you have no idea what's reason to write, you can always refer here. Okay, boiling point, critical angle, power of lens, blah, 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 blah. Okay, then here is
老师，请问什么是 focal length 啊？
focal length。等一下我们会讲，等一下我们会讨论到。
哦 ，OK， 好的。
我们先讲 Chapter 4、Chapter 5、Chapter 6。OK， 所以 focal length 你可以找 definition 这边，这个只是它的解释，就是这么你要选它。Definition 在这边 start with page 11. So this is chapter 1, Form 4, chapter 1, chapter 2. So let's say you forget, never mind, refer back here. Easy, very thin only. Okay, then chapter 3, chapter 4, chapter 5, chapter 6. 来这边focus. Focal length. Focal length is the distance. Length means a distance between focal point and optical center. Oh. Okay, so for of a lens or a mirror. Okay, so for example, this is lens. So here is the center of the lens, then this is F. Okay, so here, this is the focal length. Normally the point we use capital letter, but the length we use small letter. Like your maths also the same thing. Right? Normally we label A, B, C, point A, B, C. And then let's say here, this length we will label X, Y, Z, something like capital letter, big, small letter. Okay, so this is Form 5, Chapter 1, blah, blah, blah. Okay, so you can refer. Okay, now let's start with the Chapter 4. Form 4, Chapter 4. If you have time, can do. No need teacher ask. That's the purpose we teacher decide to give you this to practice the exam format. Okay, so normally the first question for A, for example, question if I don't reply, I'm lagging. Okay, Aaron. Normally the first question they'll ask what is something, what is the definition. So now you know where to get it. Ta-da! The definition. In case you don't want to flip back the last year book, so take a look, just find here. Okay, degree of hotness. As long as you got these keywords, 1 mark. Okay, it's degree, not amount of, not the amount of heat, it's degree. It's like indicator. 它好像一个指标这样子。Okay.
Can we say magnitude of hotness of an object?
Not a magnitude, because magnitude means something solid, some object.
Okay, okay.
Degree means it's just indicator, just 一个指标罢了。如果你讲 amount， 它是真正有1个、2个、3个的，它有量词的，这只是讲它高还是低。
明白吗？
很好。So heat is energy lah, is a thermal energy lah. Okay, so all of this thermal equilibrium must know lah. What is thermal equilibrium? I encourage you to tell 2. Number 1, net heat is 0. Second is final temperature is the same. Same final temperature. same final temperature. Net heat. May I know what is the meaning of net? Like,
Sum,
什么
can say total or sum.
sum total can say sum, but better word is subtract. Subtract. Okay, so you can draw here. This is object A, this is object B. Okay, so actually what is net heat flow? Net heat flow is 0. It's not saying that no heat flow. There is
From
500.
heat to cold, hot to cold.
Yeah. So finally, okay, let's say in the beginning it's 500 from A to B. Then B is 10 joules from B to A. But finally, when they reach thermal equilibrium, they have same final temperature. At that time, maybe this one is 100 joules from A to B, then 100 joules from B to A. So when you minus 100 minus 100, the net after you minus would be 0. Okay, the net would be 0. Okay, so be careful about thermal equilibrium. Okay, so all of this you all. Okay, heat capacity and specific heat capacity, what's the difference? Obviously, got one specific. So the specific means what? Means specifically 1 kg. So you can see the definition here. Heat capacity and specific heat capacity. Specific heat capacity got 1 kg of mass. Specific 1 kg only. Okay. So it's quantity of heat to raise temperature 1 kg by 1 degree Celsius. These three are the key. Without these three key in the sentence, wrong. Okay, then specific latent heat. Also must tell heat. Specific means 1 kg of mass to change phase, or you can say to melt, to freeze, to vaporize. Of course, I got fusion and vaporization. So this one we just say change phase. Without, must mention without the change of temperature. Also must mention 3 things. Heat, 1 kg, specific heat capacity, 1 degree Celsius. This one, change phase. Okay. Okay, so this one you complete it. Okay, so now, this is a heating curve for the metal in liquid state. Okay, so liquid state means in the beginning is liquid state. Liquid. So temperature of metal is constant from Q to R. State the type of heat involved. Like, please type your answer. Let's say H is heat capacity, L is latent heat. From Q to P. What is the heat? Can I make poll? Do you think I can make a poll here? Poll. No. Capture. Okay. Cancel. Okay, so ELL sans L 5个这个2个 Okay, what is the heat involved from Q to P? What is the heat involved? Means here got changes of temperature. What kind of heat is it? From P to Q, what kind of heat is it? Q to R. Hey. My fault. See wrongly. Q to R. Blur case. Sorry. Q to R. Q to R means no changes of heat. Sorry, of temperature. So obviously no changes is latent heat. I'm so sorry. Thank you. Okay, so this is how we see that. This is how we see that. See, no change of temperature. Let's say this is 200. From Q to P, the temperature does not change. Means, so formula for this specific heat capacity is actually is Q equals to MC theta. So C equals to Q over M theta. You all can see the formula list. Teacher, I thought question asked from Q to P. Am I seeing wrongly? Oh, okay. Now I understand why. Hi, Pipa. Oh, okay. Now I understand why. Sometimes the questions, see, this is Q to R. This is Q to P. Yeah, sometimes the questions got typo. Typo means typing error. So it's RQ to R. Oh, then I'm not seeing wrongly. It's the question problem. Then if you see this in exam, raise your hand. Teacher, may I know, is this question okay? But most less typo now. All right, so now, so state the matter from Q to R. So I just explained, right? Chalang, your naphthalene here. So since it started from liquid, means liquid and gas. And heating, sorry. For a metal in liquid state, suatu logam dalam keadaan cacair. Yeah, Lei. Who is Lei? Braden? Braden. Yeah, Braden. Yeah, 什么事 For graph can curve like that. For graph can curve like that. Sometimes is normally we draw a straight line, but sometimes, not sometimes, actually it's curved. Just we draw straight line in chemistry. So actually don't care about the curve because normally we look at the constant only. Okay, like thermometer. Name the liquid used in the thermometer. Why? Mercury, everyone know. Why? Yes, thank you, Jin. No one know. High density, low heat capacity, and sensitive to surrounding. Liquid at room temperature doesn't stick to the bucket. Okay, so I like opaque. Yeah, very good. Okay. Opaque doesn't stick to the wall. Doesn't stick to the wall, the glass wall. You all can send your message in to everybody so everybody can see. Course very good. Wow, Junfai. Wow, course very good. Very good. Why Junfai is a good student? Because he's very good. Okay, expand and retract. We can say Mercury, it expands and retract. Or normally I use contract evenly. Or we say, like Braden said, low heat capacity. Not necessary because we want the expansion. Okay, so the best is this lah. Short and nice. Opaque means cannot see through. Okay, so complete the following sentence like the thermometer. So the temperature of water is taken when liquid in the thermometer starts contract or stops contract. Sensitive in temperature change. Sensitive temperature change. Okay, can. High boiling point. Can. Good conductor of heat. Okay, good. Can. Wow. Actually is stops. Why stops? Stops is when thermal equilibrium achieved. When it achieves thermal equilibrium means finally, let's say in the beginning, 30 degrees Celsius, then this one is 100 degrees Celsius. Finally, it will stop at, let's say, 55 degrees Celsius. So stops means when it achieves thermal equilibrium. Yay. Okay, so now this is explain why the man feels cool when he's sitting in front of rotating fan. Sweating means got water, got sweat. Feels cool when sitting in front of a rotating fan. 4 marks questions. Okay, normally how I make the 4 marks. I will start with sweat, ends with feel cool. 4 marks means you must have 4 sentences to tell from A to Z. Then this is the Z feels cool. Actually, this is not, we don't count this mark, but we make this as a conclusion. So we start from number 5, then come back number 4, number 3, number 2, number 1. So this is called backward reasoning. 往前推理. Okay, like why you feel hungry? Because I just used up my energy. Something like. High airflow, very good. Rotating fan, yeah, please translate. Got high airflow. Yeah, highlight the words and translate it. Sweating means this is your skin. We all learn biology or homeostasis in Form 1. And Form 3, we learn thermionic reaction. Okay, so this is sweat. Means it's water. So it will absorb the heat and evaporate out. So why we feel cool? It's because the heat is absorbed. Hypothalamus. Latent heat of vaporization will be absorbed from our body. Thanks, Ale. Ale, show everybody, Ale. Okay, so then say endothermic. Very good. Yeah, very good, very good, very good. Okay, so number one, you tell lah, the sweats on the skin. You mentioned the sweats. Then the heat from the skin is absorbed by the sweat. Absorbed by the sweat. That heat is what kind of heat? Braden say is latent heat of vaporization. Very good. Latent heat of vaporization. Oh, number three. Number two is you mentioned absorb. Number three is you mentioned heat. Latent heat of vaporization. Okay. Then number four, when the high airflow means it gives the sweat more energy. More energy to evaporate, to vaporize. Then finally you feel cooler. So you think about step 1, 2, 3, 4, then you make your own sentence. I believe all of you, your English okay one, can make sentence. Sweat 打成 water 也可以呀 water molecule sweat 就是 water 啦。OK 可以可以。是 heat 被 absorb heat 被 absorb heat 被 absorb OK so the 4 marks question how to write the 4 marks question please. For example, this is normally B. So no need copy question. Just write maybe number 1, number 2, number 3, number 4, number 5. Or you write dash, 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 dash. New sentence, new line. Easy for teacher to mark. Okay, don't make it as essay, hard to see. Okay, and SVM can do this or not? Can, no problem. Okay, so now shows the body temperature, blah, blah, blah. So this one actually is in your module last year. So taken, so same thing lah. Number 1, you say action. Action is the thermometer. Put thermometer into mouth. Number 1 normally is isi tersurat. What you can see. What's the action? Put it into the mouth. Yeah, Chunfai. Yes. Then number 2, you mention heat. How is the heat flow? Heat flow means the heat from his tongue to the thermometer. You must mention. Then number 3, you mention thermal equilibrium. Okay. Number 4, So we take the temperature. We can use back the sentence here. When the mercury stops contract. You write as many as possible. Okay. So this one you can refer back last year. Okay, so now these questions, when they mention pressure and volume, then fixed mass, we need to think back. Okay, so we have Q equals to MC theta, Q equals to ML, latent heat, specific heat, and this one is Q equals to PT. Actually, this has come from last year, what we have also. Now, from 3, we learn power equals to energy over time. Okay, so E equals to PT. Energy, so heat energy equals to P times T. Now here, this one, can you draw out the triangle and you tell me the name? If you cannot, then the marks say bye-bye to you. Here, you can draw it here too. Formula is here. PV dt. Yay, 对 Brayden. PV over T. Yay, Jonathan. 没有啊，对啊。Actually it's here. PV, same line. PT, up, down. VT, up, down. Okay. Then remember, start from P is GCB. Don't you feel familiar, GCB? Grilled chicken burger. Okay, so PT is Gay-Lussac. By the way, must check the spelling properly. If you spell wrongly, for example, Lussac, you put one S. Sorry, wrong. Okay, so Boyle's law and then Charles' law. Okay, so now from here, what law is it? Pressure and volume. Pressure and volume. GCB. Obviously, Boyle's law. Every year, sure got this kind of question. Sure, got at least one test law. Sure. SPM every year, sure. Sure, they will ask what law is it. Okay, but this is, of course, this is 4 marks question. Okay, and actually they already give you Boyle's law. Then they ask you to explain the relationship between volume of gas by using kinetic energy of gas. More kinetic energy, they will move faster. So volume increases or something. Gas will be compressed with temperature then constant. Volume. Sorry, my fault. I use another law. Yeah. So when volume decreases, pressure increases. Kinetic energy, sorry, does not change. Kinetic energy comes from heat energy. Since here got no heat energy, so kinetic energy is constant, right? Okay. But volume decrease, pressure increase lah. Yes, Braden. Frequency of collision and the wall increase. Yeah, Braden, very good, Braden. Okay, so in case you don't know, actually behind got answer. Behind got answer. Wait. Behind got answer. Okay. Some is PM lah. If you are not sure, then ask teacher or ask your friend. Okay, so now I want to go to the. So all of this you can do lah. Yes, Braden, show to everybody. Okay, then you all can try the calculation by using the PV over T. One more thing. Remember, this T is absolute temperature. Means, let's say 27 degrees Celsius, please change to 300 Kelvin, right? This one, this T. Many people forget after 1 year. So this one you try, So okay, like this question, page 37. Okay, so this is 10 marks questions. When you see 10 marks question, what should you do? Table, very good. Don't forget, physics paper 2 need 1 test pad. Paper 1, I will prepare. I'll prepare the OMR for you, but you still can keep the OMR because your trial also can use. Okay. Okay, so table like this. You don't write table, you die. Okay, characteristic. And this is choice. This is reason. Okay, this kind of questions we call it as decision making. Okay, decision making. Okay, then here got small trick. Many people work that down. Okay, from number 1. What is the specific? Now you write a specific heat capacity. What is the specific heat capacity should be for the cooling system? Should be high or low. Okay, high, low, high. Wow, Braden 很好。 Okay, then second, I think all of you know, melting point. That means next number 4, the rate of expansion. Okay, so answer is 350. Am I correct? Thank you, Jin. Okay. Okay, this one I discussed and fine-tuned it already. Some you haven't tried. I give you 1 minute. Fast. Answer if you write like this, sorry, you will see your teacher give you wrong. Give you wrong. Why wrong? Because we want adjective. The adjective means what? Means low. Okay, we write low. We write low. Okay, so this one we can see. What's wrong to my computer? Oh, yeah. Scared me. Okay, high specific capacity means we'll get hot slower, but also in temperature increase lower. So will cool down slower high. So actually we want low specific heat capacity, heat up faster of course, but cool down also faster. Okay, so how does it work? I7 actually it's the wind will flow through it. So low specific capacity actually can heat up or cool down. They want cooling so cool faster. Alright, so now melting point should be high. Be high. Why high? So that not melt easily. Okay, then I encourage you to write one more reason. This is can heat up faster. One more can say temperature we copy here. Shorter time to drop temperature. temperature drop faster or drop in shorter time. Okay, encourage you to write two reasons. Don't write 10, 2 enough. 2 to 3 enough. Okay, not melt easily, so we can say withstand high temperature exhaust fumes. Something like. If one correct, one wrong got marks, yes. Yes. Let's say that this one wrong. But this one correct. Okay, so normally how we mark, this is mark 1, mark 2. Mark 3, then, let's say this one wrong. But you still got backup. Yes, you still can get the 4th mark. So do not worry. So better write 2. Okay, fin color should be black because black can absorb heat faster. Here, color, don't use the word conduct. Can conduct heat faster. Don't use the word conduct. Conduct is material. For example, they mention metal. Because what's the difference between conduct and absorb? Oh my God, I think today I cannot finish. Okay. Okay, absorb means the surface. Absorb heat, the surface absorb heat. Conduct means the heat goes through the whole conductor. Okay, so conduct is used for material. Color, we say absorb. Then one more reason is
radiate. Should it be radiate heat?
Yes. One more, correct. One more is here. I have no space, I already draw here. So one more you can write. Can radiate heat faster. Yes, can radiate heat faster. Don't use conduct. Okay. Okay, absorb means the heat. Here is the surface. Absorb means the heat absorbed. Radiate means it release out. Radiate means release out. That's very good. So the cooling fin will absorb the heat from the engine and release it out, means radiates out faster. It's a good heat radiator. Same meaning as this. Can radiate heat faster is a good heat radiator. Yeah, very good. Good heat radiator. Good. So please write at least 2 reasons as backup. Okay, then you might say, teacher, in real life, I seldom see a black cooling fin. Correct. Because this is the original color of the metal. Okay, but if you want the better efficiency, black is better. But of course, black will increase the cost now. And some more cannot use normal paint to paint it because it's quite hot. So if you want to paint it black, it will be high cost. Polished surface is the best radiator, and black surface is the best absorber. I'm not so sure about it, but I will take your point later. I check Google. Okay, so I finished this first. Rate of expansion should be moderate. So if you make high, means later this one expand too much, then your motor damage. Okay, so rate of expansion. Why reason? Remains its original shape after contract. 热胀冷缩，对不对 ？Hot expand, cool contract. So 热胀冷缩过后，它可以 remains the original shape. Something. So I encourage you to write 1, 2, 3, 4, 5, and number 5 will be your choice. So your choice will be J. And then here you just repeat that because it has low specific capacity, high melting point, black fin color, moderate rate of expansion. So this is how we check. If you got 1, 2, 3, 4, 5, you won't forget. So 1, 3, 5, 7, 9. Then 4, 6, 8. So this is how teacher mark that normally. Odd number for the point for your choice. Even number is for your reason. Okay. And one more thing. Effective means. Some of the words here you don't use back as your reason. If not, you got no marks. They don't want you to repeat. 老师, I have an urgent method that I need to attend, so I'll be leaving. Thank you. Sorry, no problem. I will upload to YouTube. No problem. Bye. Okay, so now this one you all do. Okay. So this is defrost plate. Malaysia seldom need it. Our weather is hot enough. YouTube name is Cikgu Sir, right? Yeah, later after I upload, I share my link to you all. Okay, so now wavelength. So same thing lah. If possible, you try first. Then only you look back to the definition. Okay. You try first, then only you look back. So there will be chapter 5. Now everything is here. And actually you can modify. If you read back last year's book, I already told you some keywords. As long as you have the keywords, you modify your sentence as matter. Okay, so now name the phenomenon. Okay, now teacher, I'll leave the meeting because I have another tuition. No problem. Later I upload. Okay, bye-bye. Okay, so now we got 4 phenomenon. Okay, this phenomenon is quite. No one can answer. Phenomenon normally is reflection, diffraction, and interference. Yay! Yeah. Everything good. Good. Yes. The rest. Jacqueline, yes, really. And this, yeah, this is refraction. So refraction, normally we say got two medium, less dense and denser. Yes, refraction, Marcus. Okay, so here, if we draw the side, this is top view, this is top view. And this is side view. So if we draw the side view, it will be like this. This is the seabed. This is the seabed. So here deeper, here shallower. Okay, so needs you to revise back. Like deeper means velocity higher, lambda higher. Shallower means velocity slower, lambda shorter. Okay, this is refraction. So be careful when they mention phenomenon of wave, only got 4 answers. 1, 2, 3, 4. All right, 1, 2, 3. Okay, so this is diffraction. What is diffraction? Okay, check back yourself. Okay, and this one is a must to memorize. Okay, it's a must to memorize. Teacher, wavelength shorter means denser, right? Wavelength shorter. Yes, correct. Yes, correct. So we also can say deeper means, we also can draw like this. Deeper means liquid, more liquid. Like, okay, so this is liquid molecule. This seabed normally is sand. Seabed is sand. So you can draw back and you imagine back. So you can see that shallower means denser. Deeper means less dense. Dense or denser actually is how compact is the molecule inside. So since more solid, this is denser. Liquid, less dense. So why shallow part is denser? Oh, okay, yeah. I think I explained to you. Okay, shallow part means more sand, more solid, denser. So like that. Okay, this one is a must, it's a must to remember. So radio wave, microwave, infrared, visible light, ultraviolet, X-ray, gamma. Okay, so radio wave have longest wavelength, gamma ray has shortest wavelength. So V equals to F lambda. Since F, so lambda increase, F decrease. Lambda decrease, F increase. So how to remember? Like RM, Ringgit Malaysia, I love you, X gamma. Okay, then visible light, you must remember the color of visible light is Roy give birth. Okay, normally Chinese can remember Roy because in primary school we already memorized the color rainbow. Okay, or in English is Roy give birth. Red, orange, yellow, green, blue, indigo, violet. It's a must to memorize, especially in Form 5, Chapter 7. We will need it again. Or Chapter 6 also need. Chapter 7 also need. Okay, can you remember RM, I love you. IVU means I love you, X gamma. Visible light, Yeah. Red has longest wavelength, violet has shortest wavelength. Okay, then name the wave for P. I means infrared. Q means ultraviolet. Okay, so the meaning of infra is more. Okay, sorry. My fault. It's less. I don't like it. Infra actually means less. Ultra, it is more. Okay. What is less than visible light? The frequency less than visible light. So infrared. Then more than violet, ultraviolet. Teacher, what if I just put UV short form? UV. I'm not quite sure. But if current AC, DC are acceptable, UV, I'm not so sure. You better write full. Okay, I'm not so sure. Okay, so now the wave here, blah, blah. This is light interference. Blah, 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 blah. Okay, so you will try. But I will look at this. H485. Evaluating. Page 45. Strong retaining walls are usually built in a sea near to the harbor jetty to protect boats from damage caused by strong waves. There have been assigned an engineer to assemble a retaining wall to build in front of the new harbor. 4 models of the structure. Blah, 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 blah. Okay, so now which one is the best? S. Foot. 1 foot. S. A. Marcus. S. S. Okay, good. Yeah, S. Okay. So what shape is it? Same thing. This is 10 marks question. So please read here. Always read back the question. Highlight the criteria they already mentioned. Blah, 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 blah. Suggested location. Okay, see here, got any reason you can repeat? They are asked to build a strong and safe harbor. Please do not use strong and safe as your reason here. Study the characteristic in table 6. Explain the suitability of those characteristics and determine the most suitable design, characteristic, and location of the harbor. Okay, so don't write strong and safe as your reason. The rest okay. Okay, then this one. There doesn't write any words. How can I answer here? Never mind, you just draw here. And you just draw back. Yeah, you just draw back this. Yes, to withstand high pressure at the bottom. Yeah, so if possible, you write something. So we say is thickening at the bottom. The shape of the wall must be thickening at the bottom. Okay, you explain if possible. If you try to write some words, some sentence to explain it, and you can draw it up. Okay, if you have no idea what to write, then you draw out. Okay, so thickening at the bottom to withstand, because P equals to H rho G. So higher the depth, higher the pressure to withstand high water pressure at the bottom. Can I say slanted? Slanted, 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 slanted. We mentioned the bottom. Okay, so concrete. Why? Because it is strong. Okay, now. Don't use strong. Use other word. Durable, very good. Stable, yeah, stable. Durable, yeah, don't use back the word. And the reason is don't want the students copy paste the question. They want your other word, your idea. Can withstand the impact from the waves? Yes. Withstand the impulsive force from the wave? Yes, can. Okay, now bay. Why bay? Why not cape? Why bay? Beach means the bay. Why not cape? So we put the retaining wall here. Yeah, slow speed. Yeah, because it's shallower, so the wave speed is slower. Wave speed is slower. Very good. Shorter wavelength. Yeah, wave speed means shorter wavelength. Calmer. Very good, very good. Calmer. Energy is dispersed. Yes, very good. Yes, yes. Energy of wave is dispersed. So you can look back here. Energy is dispersed. Okay, so several opening at the wall so that the ship, the boat can this is real life retaining wall. Now this one, some opening. Okay, so narrow gap so that diffraction occurs too. Okay, then you can see the harbor normally got the retaining wall like this. like this. Okay. Okay, so this is the suggestion and reason. Concrete retaining wall, uneven surface, so they can absorb the energy also. Like why we put curtain, carpet, cushion in the cinema, because all of this got uneven surface and also can absorb the energy. Okay, so now, so this one to allow ships enter in, more ships to enter at one time. Because if you only have one opening, one ship or two, I think only one ship can go in one time. So can allow more ship enter. Okay, more ship enter at one time. Okay, so okay, now mobile phone. Which one is the best? So what's the reason for opening? This one, allow. Sorry, I didn't type. Now, retaining wall has X-ray. Now, allow more ship to enter at once. More gap. First, more gap will allow more ship to attack, to enter. Second is narrow gap can make diffraction occurs, make the wave calmer. Also can say makes the wave calmer. Diffraction occurs means the wave will be calmer. Okay, so now. Okay, so this must be electromagnetic EM wave. What is the EM wave? Just now we memorized RM, IV, U, X, comma. What is mechanical wave? For example, guitar waves. For example, sound wave. For example, water waves. Okay, so electromagnetic wave got all types. Then all of them will have light speed. C equals to 3 times 10 powers of 8. Where is it in your formula list? At the last. Second page. Here. Light speed. Mana dia? Sorry. Second E equals MC squared. C equals to this light speed. Light speed. Okay, because it has light speed, high speed lah. Okay, why all tinggi? I think something wrong. This should be low, this should be low. Okay, then B, panjang gelombang. I think this one should be high, low, high, low. Typing error. Okay, so now area coverage must be big lah. So I think answer would be P. Okay, then normally our GPS in our handphone is using microwave. Because we need to communicate with satellite. So only microwave can make very good job because it has consider long wavelength, but the most important thing is high frequency. High frequency can penetrate through the atmosphere, right? Okay, so this one, I believe all of you have very bad experience in this sun. And do not worry, PIBG and our PK are discussing how to improve it. Yes. Okay, so 10 marks. Yeah, welcome to solve the problem. Okay, so now the light and optics. Okay, incident angle, virtual image. This one very common to us. What is a virtual image? Virtual image means doesn't mention, I think. Here, virtual image means image cannot be formed on the screen. What is real image? Image can form on the screen. Apa itu? For example, mirror. When you look at mirror, can you make the image in the mirror? You project it on the wall? Cannot. So the mirror image called virtual image. Projector. Projector can form the image on the screen. Yes, that's real image. All right. So real and virtual. Focal length. What is meant by focal length here? The distance between the focal point and the optical center of the lens. Okay, what is meant by focal length of the mirror? Means the distance between, from mirror, for example, is the distance from the focal point to the axis focal point of the mirror. CF. I forgot what is the name. Later I check and let you know. This P. Okay, so now definition of Snell's law. Snell's law is here. N equals to sine I over sine R. And don't forget, this I must come from less dense medium. Okay, for example, here I got two medium. This is glass, this is air. So the light like this, then refract away from normal. So here is I, here is R. Let's say this I is 30 degrees, this R is 60 degrees. So what is the N? N equals to sine. The I, even though is here is gas, but we take R as your eye. Because when the light go this way, then it will terbalik in the same angle. It will terbalik in the same angle. So actually this eye is for less dense medium. Please use 60 as I. Then sine 30. Okay. Okay, so total internal reflection critical angle goes to check. Okay, now calculation. Okay, this calculation power is not given, so you must memorize the formula for power. Formula for power is power equals to 1 over focal length in cm. Power equals to 1 over focal length in cm. Sorry, in 100 over cm. Or P equals to 1 over F in meter. Apa itu, for example, an object is placed 30 cm in front of a lens with a power of positive 5 diopter. B is diopters. Okay, so calculate the focal length. So we use P equals to, since they give no need, 1 over F. So what is F? F equals to 1 over P. So F equals to 1 over 5. Means F equals to 0.2 meter. Means F equals to 20 cm. Okay. So this two formula is not given for power of lens. Not given. So it's a must to memorize. If not, you lost the marks. P equals to 1 over F in meter, or P equals to 100 over F in cm. Okay, then image distance, we use this formula, image distance. So I believe you all have basic skill for linear equation. You can solve it. Now, magnification of the image. So actually it is same as your, I should put like this. It is same as your magnification. So K equals to PA prime over PA. Prime means image. Then this is object. Okay, so formula is given one only. Actually got one more. M equals to height of image over height of object. Okay, what is V and what is U? This is the lens, so this is F. This is F. This is 2F. So U means if the object is here. U, the object is here, so this is U. From the object to the lens, the distance between object to the lens. Then what will happen? The image will be here. So here, from the lens to the image is V. So linear magnification means V image distance from the lens divided by object distance from the lens. Or sometimes they'll give, this is 4 cm, let's say U is 20, F V is 40, then what is the height of the image? So we will simulate these two formula. So this is here the two formulas not given. Or I encourage you to write on the first page when exams start to remind yourself. But of course, don't copy on the hand and then you bring in. That's called cheating. Okay. Okay, so magnification, we will use V divided by U. Since we get this is U, this is V. Okay, so now okay, so this is the microscope and telescope. So you will see the combination here. It might be complicated to you. I think I will explain it next week. Okay, so then I hope you all can go study back telescope, microscope, and then how to draw the light ray on the lens first. Okay. And next week we will talk about chapter 1 to chapter 3. Actually, it's shorter. Okay, chapter 1 and chapter 3 I think quite easy. So I will talk about the telescope, microscope. Okay, so any other questions? If you still have questions, can stay back and can ask lah. Then if you have no questions, you can leave lah. Okay, thank you everyone. Bye-bye. Good night. No. Hi, Nazim, Brenda, Jacqueline, Jacqueline.
老师，我还是不是很理解那个光还有那个波。
你是谁？不好意思。
你
一送。还有什么光？什么光？你相信？
那个像 reflect， 还有那个画的那个，跟那个那什么 frequency， 那个不会那个还有那个frequency 那个什么？
什么？再讲一次。
那个 frequency 啊，就是很像那个波的那个 wave 啊 wave。
wave 什么？
这两个我还不是很熟。
我不明白什么 frequency 什么酸呢，还是 diffraction 呢 ？phenomenon 你不懂呢，还是什么
phenomenon？光是 phenomenon， 然后 wave 是那个我会看它的那个 frequency， 还有那个 wave 那个lambda。
B 等于 F lambda？你讲的是哪一题？这题？还是刚刚讲那个 shallow deep 那个？
对，这个下面那个 light 的那个 UV。
下面这个
对，我还是搞不清楚 V equals F lambda 是F 是 frequency，lambda 等于
lambda 是 wavelength 吗？
wavelength， 然后 V 是
wave speed。 wave. 好，这个是 side view。OK， 来，我开始滴水了。我增加 frequency 看到吗？
看到。
所以你看，这个是它的 waveline 1.8，然后我们写一下，这个 high frequency 的 lambda 是1.8 cm。然后我们调一下 low frequency。好，我们看 low frequency 和 lambda 整54.7。4.9了 ，OK， 所以 low frequency lambda 4.9 cm 咯。那我们来看，比如讲这个 frequency 是10好了，所以 V 等于 F lambda，F 是10 ，lambda 1.8，所以是18 centimeter per second。这样这个呢 ，V 等于 F lambda。比如讲这个 F
cm per second。
对，
没有0.049。
这样它相乘就等于 wave speed 咯。你看它就很慢，但是如果 high frequency 它就很快，所以它 wave 也很快。好，我有回答到你的问题吗？
有。然后另外一个就是那个 phenomenon， 我不懂，就我只懂 reflex 是反射 ，refract 是折射，然后那个 infer 我不懂，那个 differ 我知道是颜色，就是interference 呀。
diffraction 其实就是 spreading of wave when the wave propagates through a slit or a side of barrel。就讲它从一个，比如讲刚刚这个，你看这里，这个就是 diffraction 哦，它的 spreading 就是它本来是直直来的嘛，可是它经过这里，它就散掉了。然后我们比较一下跟它原本的，看到吗？它的 direction of propagation 散掉了，这个叫 diffraction。
OK。
或者是本来它是，这是 wave， 它来到 barrel 就是挡着它的东西的时候，它就会慢慢收起来咯，收起来就讲那个 wave 会慢慢合起来。 这样子，这里就空出来了，这个也叫 diffraction 了，就是 spreading 啦 ，spreading 就是它经过过后，它的形状会改变，它的 wavefront 会改变。好 ，interference 是什么？是 two or more wave from the coherent wave， 所以他们会记得吗？我们上次画过的。有 note 啊 anti note 啊这些，我们去年有画的。
有诶。
拿去年的那些纸做一个，哪里去？这个没有，我们去年有。就是它两个 wave 会交叉在一起 ，not anti not 有吗？有吗？有吗？然后现实生活中我们用它来做什么嘞？
拿来好像放 speaker 那些。
earphone 就是比如讲降噪。
就好像两个波是相反的，所以他们两个可以综合掉，不可以叫综合，叫 normal line。
对，所以这个叫 disruptive interference。然后如果它加起来很大声，那个叫 constructive interference。然后你还要能够解释咯，你还要能够解释什么是 constructive interference， 什么是 disruptive interference 哦。
normal 跟 innormal line。
node line， 什么是 node？N-O-D-E， 什么是 node？
平的。
对 ，node 可以讲是一个动，它是平的。anti node 就是讲它不是动，它有东西的，这样子咯。这里好像没有什么，除了这个好像没有什么 interference。有 light interference。这是 reflection 忘记讲了 ，reflection 也没有。
反射 reflection 是反射，是吧？
反射是，
我还是分不清 reflex 跟 refract 那个音太重要。
reflect 反射，所以它是这样子。这个 wave 这个 boy 他喊嘛，所以那个 wave 去到这里50，他听回来的时候就是那个 wave 走了100，50加50 100，所以这一个的 formula 没有给，但它其实是拿 form 4第二课的 v 等于 s over t。velocity 等于 s over t， 所以 velocity 等于2个 d， 2个 distance 除 t， 然后找什么 time interval， 所以 t 等于 2d over v 咯，所以 t 等于100除 velocity 340，这样子咯。这 formula 忘记讲了，刚才。
v 个是 2d over t， 就是2来回 over d。
对，所以 v 等于2d over t， 因为它 reflect 的意思就是它去了又回来，所以它的 distance 2倍的意思。这个 formula 也没有给。 那这个 double slit 这个也是 interference 来的咯。所以我想问一下，一松，请问0.05米这里有几个 x 呢？哎呀，还有就是 lambda 等于 ax 加 d，ax over d，ax d 有个别代表什么？这个也要去复习。什么是 x？
它的间隔。
对 ，x 就是 node 到 node 的距离，或者 anti-node，node 到 node 或者 anti-node 到 anti-node 的距离。所以这里是1个、2个、3个、4个、5个，这里有5个 x，所以5个 x 等于0.05米的，1个 x 其实等于0.01米的。这个也是很多人会 confuse 的地方。
差点 confuse 了。OK，
不过时间有限我没有办法一个一个讲。
可以了，已经 get 到了，get 到了。
好啦，还有问题吗？
OK，谢谢老师，Thank you，
看，
拜拜。
拜拜。